previous videos, we learned how the coefficient next to the whole function or next to the argument affects the graphs of those functions. In this video, we will look at what happens with the graph of the function when we add or subtract a number to the function or to the argument itself. In a few examples, we will look at the horizontal and vertical translations. And we will start with the horizontal translation.
In this example, we will graph one complete cycle of y equals sine of x minus pi over 2. Later, we will learn how to graph a trigonometric equation that has a number next to the argument without having to make a table. But for now, we will start with creating a table of values. For x values, it will be more convenient to use multiples of pi over 2. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. We will now substitute these values in the equation. Y equals sine of pi over 2. We substituted x with the pi over 2 minus pi over 2. Simplify. Y equals sine of 0 equals 0. Pi over 2, 0 is the first point. In the same manner, let's complete the whole table. Now that we found all the points, let's draw a coordinate plane and transfer these points on the plane. First point, pi over 2, 0. Second, pi, 1. Third point, 3 pi over 2, 0. When x is 2 pi, y is negative 1. And 5 pi over 2, 0. Let's connect the points. This is the graph of y equals sine of x minus pi over 2. I'm also going to draw the graph of y equals sine x, so we can compare the two graphs and see what changed. As we can see, the graph of sine of x minus pi over 2 shifted by pi over 2 units to the right of the graph of sine x. In the second example, we will graph one complete cycle of y equals 3 sine of 2x plus pi over 2. What we already know is that the coefficient next to the equation will change the amplitude of the graph to 3, so the range of y values will be from negative 3 to positive 3. We also previously learned that the coefficient 2 next to x will shorten the period of the sine graph by 2, from 2 pi to pi. So we will use multiples of pi over 4 rather than multiples of pi over 2 for the values of x, just so they're a little bit closer together. Now let's substitute the values of x in the equation. When x is negative pi over 4, y is equal 3 sine of 2 times negative pi over 4 plus pi over 2 equal 3 sine of 0, which is equal to 0. So the first point is negative pi over 4, 0. Let's continue for the rest of the table. Sine of pi over 2 is 1 times 3 equals 3. The second point is 0, 3. When x is pi over 4, y is equal 3 times sine of 2 times pi over 4 plus pi over 2 equal 3 times sine pi. Sine pi is equal 0. 3 times 0 is 0. So the third point is pi over 4, 0. Now let's transfer these points on a coordinate plane. Remember, y values changed from negative 3 to 3, and x values from negative pi over 4 to 3 pi over 4. Let's transfer the points. Negative pi over 4, 0, 0, 3, pi over 4, 0, pi over 2, negative 3, 3 pi over 4, 0, and connect the points. We can see from the graph that the horizontal shift is negative pi over 4. Now let's look at the steps to graph a complete cycle of sine or cosine equation. We will look at the sine equation in the general form. Y equals A times sine of bx plus c. First, we'll need to identify the amplitude, which is equal to the absolute value of the coefficient A. Next, we will identify the period of the graph, which is equal to 2 pi over the coefficient B. Next, we will be calculating the phase shift, which is equal to negative c over B. Then we will need to label the x-axis. To help us with this task, we can use the following trick. The period of the graph is from A to E. So in the middle, we will have 1/2 of A plus E, the midpoint. A identifies the phase shift. E identifies the phase shift plus a period of the graph. Between A and point C, we will have a midpoint as well, which is equal to 1/2 of A plus C. Let's name it point B. In between point C and E, we will have another point. Let's name it point D, which is a midway between point C and point E. Why do we use 5 points? Well, if you look at the sine graph, you will notice that the sine graph has 5 major points where the graph either intersects the x-axis or changes the directions. That's why we use 5 points to build a frame. Now that we know these useful tools, let's build a frame and graph one complete cycle of y equals 4 times sine of 2x minus pi over 3. To build a frame, we need to identify the amplitude, period, and the phase shift of the graph. I'm going to write the general form of the sine graph. Y equals A sine of bx plus c, and identify the coefficients A, B, and C for our graph. Coefficient A is equal 4, coefficient B equals 2, and coefficient C equals negative pi over 3. The amplitude of the sine graph is equal to absolute value of coefficient A. Absolute value of 4 equals 4. The period of the sine graph is equal to pi over B. 2 pi over coefficient B is equal to is equal pi. The phase shift of the sine graph is equal to negative c over b. Negative coefficient c is negative pi over 3 divided by 2 is equal pi over 6. We can now build a frame. Let's start with labeling y-axis and x-axis. Y-axis ranges from negative 4 to 4. On the x-axis, we will start identifying the phase shift, pi over 6, and the period, pi. The last point will be pi over 6 plus pi. Find common denominator. Pi plus 6 pi is 7 pi over 6. Now we have two choices here. First, we can mark the midpoints. The midpoint between pi over 6 and 7 pi over 6, let's start with that midpoint, is equal to 1/2 of pi over 6 plus 7 pi over 6 is equal to 8 pi over 12 reduced by 4, 2 pi over 3. And the next midpoint will be between pi over 6 and 2 pi over 3. 1/2 of pi over 6 plus 2 pi over 3. Find common denominator. 4 pi plus pi. 5 pi over 6 times 1/2 is 5 pi over 12. And the last midpoint between 2 pi over 3 and 7 pi over 6. Find common denominator. 4 pi plus 7 pi, 11 pi over 6 times 1/2, 11 pi over 12. That's one way to identify these points. The other way is to look at the frame. And notice that these points divide the frame into 4 equal parts. So if we divide the period of the graph, which is in this case pi, by 4 intervals, each interval will be equal to pi over 4. So we can start with adding pi over 6 plus pi over 4. It will give us 5 pi over 12, check the math, plus another pi over 4 will give us 2 pi over 3, plus another pi over 4 will give us 11 pi over 12, and plus another pi over 4 will give us 7 pi over 6. Whichever way you feel more comfortable, please use it. Now let's put the points on the graph and connect the points. Here's the graph of y equals 4 sine of 2x minus pi over 3. And finally, let's talk about vertical translation. Vertical translation of the graph y equals a sine of bx plus c happens when the coefficient k is added to the graph. If the coefficient is positive, the graph moves up k points on y-axis. If coefficient k is negative, then the sine graph moves down k points on y-axis. I hope that was helpful. For more videos, check my YouTube channel, JB Math for You. We'll see you next time.